How's it going, everybody? I'd like to welcome you to the MPLS Layer 3 VPN section. So I'm like super stoked to get into this. Like I can't even wait. So I'm gonna be doing the MPLS section of videos maybe a little out of order, maybe a little unorthodox to what you might see in other deliveries of MPLS. But the reason why I'm doing it, the direction I'm doing it in, is so that everybody understands that you have an operational configuration up and running first, and then you can go through the process of playing with the other capabilities, like then playing with MPLS specific features, doing your traffic engineering, so on and so forth. So we're going to have a variety of different things going on, and so on and so forth. So the blue routers that you see that are turned on currently right now are the ones we're going to be working with initially. So it's going to be just one customer, and how we're going to go about doing that is get everything up and running, be a multi-step layout. I'm not going to have really long videos. They're going to be rather short. I'm going to shoot for 20 minutes or less. That's my goal, so that they're rather concise. We'll talk about whatever it is we're working on and then go from there. So as we progress through the sections and stuff like that, it'll grow as we're going along. But the videos will be organized in such a fashion to where it'll be very obvious what the topic is going to be and what we're going to be covering. So let me just give everybody a high-level overview as to what we're going to be taking a look at in this initial set of videos and stuff like that, so that everybody's on the same sheet of music and stuff like that. So let me kind of give everybody the high level of what this initial topology is going to look like and what we're going to be dealing with. So the initial large set of routers in the middle here, this will be our MPLS Layer 3 VPN service provider. So we're going to go through a crawl, walk, run approach. We're going to dive into the details of how the MPLS Layer 3 VPN feature works, what the service is designed to do, things like that. We're not going to spend a ton of time on the theory, though. We're not going to sit here and spend hours talking about architectures and stuff like that. That ship sailed a long time ago with a bunch of other training that's already out there. There's a lot of really good books that covers the architecture and stuff like that. So I might pull a couple of specific excerpts from those books and stuff like that that are relevant to the technology or the feature that I'm working on. But for right now, we're going to be focusing on more of the implementation. How do you get the particular feature up and running? Why do you need a particular command to be set up the way that it's set up? Things like that. And then once we get into it, we're going to lay it out in a step-by-step approach. So depending on where you are in your understanding to how MPLS Layer 3 VPNs work, we're going to first start off with setting up the service provider itself. So we'll start off with getting the IGP. In this particular case, it's going to be OSPF and process ID 100. We're going to enable that everywhere in every interface. That's a core facing or provider edge facing interface. We'll get that squared away, and then we will go forward and get LDP working. So it'll be IGP and LDP at the same time. Once we have all of that up and running, then we'll move into VRFs, and then we'll dive into multi-protocol BGP for setting up the VPN service. Then we'll take a look at PE2CE routing, spend quite a bit of time on getting all of that type of stuff working. And once we have all of that operational, then we'll go ahead and focus on some of the other tasks and features and capabilities that are available, focusing on LDP specific capabilities like authentication, session protection, so on and so forth, synchronization. Then we'll dive into MPLS traffic engineering and how all of that works. Then once all of that is done and we've covered MPLS Layer 3 VPN and as far as we can pretty much take it, then we're going to add in some other things like inter-VRF aware communications. We'll take a look at MPLS as an internet service, VRF aware internet, things like that. So it's going to be a lot of interesting capabilities and features that we're going to be throwing at this topology and setup, but that's basically how we're going to be going about doing all of this. So with that being said, let us begin with the initial understanding of what we're trying to accomplish here. So I'm going to pop in and out of the video periodically as we're going along, and that will help you guys understand where we are in terms of the video and what the topic is that we're going to be covering and nailing down. So this is inside of Eve. It's Eve NG. I don't run the pro version. There's nothing. This is the latest and greatest version of Eve. Actually, no, it's not. It's slightly older, but still, it's a relatively. It's Eve, right? It's all you need to worry about. I'm not going to be using GNS3 for the majority of our topics. I won't be using ESXi images for the majority of our topics. I will be migrating back over to ESXi when we start talking about segment routing, because segment routing is going to be one of those topics that pretty much requires the iOS XR v9K with latest versions of code, because of the new segment routing capabilities that are available to that. Though that'll be coming out in the future. Right now, we're not going to be really dealing with that. So let's understand what it is that we're here to understand in this particular video, because we need to understand the nerd knobs and things like that we are going to be going forward with. So the first set of things that we're going to need to understand from a high-level perspective is, what is MPLS Layer 3 VPN? So what is it? What does it do that I need to be aware of, and things like that? So the idea basically behind the Layer 3 VPN service is you want to be able to provide routed functionality or routed capability or routed reachability, however you want to word it, look at it, carve it up, dice it up, and serve it. We need to be able to provide a routed reachability option to all of our locations that our particular customer or customers might need. And that's going to be how we deliver that, is through an MPLS Layer 3 VPN. In other words, what's going to happen is there will be a configuration, and it's going to be a multi-step setup. So in order to really understand how MPLS Layer 3 VPN works and the nerd knobs behind it, we really need to do a little bit of whiteboarding to understand the conceptual components of what's actually going to be happening. So let's first start off with understanding what it is that MPLS and Layer 3 VPN does. So MPLS Layer 3 VPN, in its simplest terms, is relying on the service provider to provide you a service to interconnect all of your locations. Let's say we have a location here I'm in, that's a horrible W, Wisconsin. And maybe I have a site over here in Florida, where I would much rather be, because it's cold in Wisconsin, and I don't like the cold. So we have Wisconsin. This is where our primary location is at. And we have a location down here in Florida. Where in Florida, it doesn't really matter. There's really no part of Florida that's cold. So we take a look at it from that perspective. In order to deliver a Layer 3 VPN service, there's actually multiple steps and multiple services that are working in congruency with each other. So they're working together in order to deliver a service. The first one is going to be IGP and LDP. Now, this is going to be the first step. This needs to happen out of the gate in order for this to work. Why does it need to be there? Well, in order for MPLS to work, it needs to have labels allocated and distributed everywhere in the service provider core. Well, in order to do that, we need some sort of labeling mechanism. One of the ones that we're going to be taking a look at first is going to be LDP. We'll take a look at other options down the road, like RSVP for MPLS traffic engineering. Then we'll take a look at BGP labeling for more some other aspects of how this will all come together. And then we'll take a look at segment routing. Now, this is going to be the first step, and this is going to allow us to connect everywhere inside of the service provider network. So that's going to allow CSR1 to talk to CSR5, or I'm sorry, CSR6. CSR6 to be able to talk to CSR32, and CSR6 to be able to talk to XRV9, and CSR1 to be able to talk to CSR32, and CSR32 to be able to talk to XRV9. So what did I just draw out? I drew out a full mesh of connectivity to all of our locations. So if we were to clean this up a little bit, let's try this a little bit differently here. We're going to have connection here, we're going to have a connection here, and we're going to have a connection here. To all these guys, a connection here, and a connection here. That's a full mesh of connectivity. Basically, LDP, its main job is to basically build a label forwarded path See, so that CSR1 knows how to reach CSR6 not via IP, right? We're not trying to IP route traffic inside of the service provider backbone. We are trying to label forward traffic in the service provider backbone. That's why we use LDP, because we want to allocate, we use LDP to allocate a label value for every IP prefix that's known about inside of the service provider core. Now, once that's done, we have a couple of other things that we need to have up and running. So the second one and the third one and the fourth one. The second one and the third one, it's really up to you in which order you do this in. It's not a do one, then do one, then two, then three, then four, or do one, then three, then two, then four. It really doesn't make much of a difference. The reason why I say that is because whether you set up the VRF, whether you set the VRFs up first, or you do the IBGP, VPN, V4, V6 peerings, the order in which you do the VRFs or the IBGP, VPN, V4 peerings doesn't make much of a difference. There's absolutely, oops, 1 second, folks. There's actually zero difference. It doesn't matter which way you do it, as long as you do it. I don't care which order you do them in, just do them so that the features are enabled. I don't care if you do the VRFs first or if you do the BGP. Normally speaking, though, most people that I know that do MPLS Layer 3 VPN, they do it on a pretty regular basis, will do IGP and LDP, then the VRFs, then BGP. So I should say that. So they'll do, yeah, they'll do IGP and LDP, then they'll do the VRFs, then they'll do BGP, because BGP can be combined in for this where we have PE to CE routing. And that'll be the last step that needs to be brought into play. Let's talk about each one of those real quick. What's the VRF designed to do? The VRF is designed to take the connection from the customer-facing connection. So in this case here, gig 3 on CSR1. The connection here, gig 3 on CSR32, and gig 4 on CSR32, as well as gig 2 on XRV9. It's designed to take these interfaces facing the customers and put them into a different routing table, so that when traffic is received by the customer, it's in its own unique routing table. And then what's going to end up happening inside the VRF is you're going to have the ability of taking routes out of the VRF and place them inside of BGP, where you'll have peerings set up, or you could be setting it up. It may not be done when you set the VRFs up, but you will at some point have IBGP peerings set up between all of the PE routers. And then what's going to happen then is you're going to allow routes to leave the VRF and go into BGP, and then you're going to take those routes that were injected into BGP, and then you're going to put them back inside of the VRF. What they refer to this process is called the route target import export policy. And the idea behind that, in its simplest terms, is to allow traffic to be received inbound by or leave outbound from the VRF. That's going to allow traffic from Wisconsin to reach Florida, and from traffic from Florida to reach Wisconsin. That's the main goal here, right? So we have a situation like that, and everybody is happy. So in terms of how this all comes together, the VRF allows the customer traffic to be segmented. That's its whole goal. Now, as we're going along and talking about this, the next step is going to be the IBGP VPN v4 peering. Now, how is this unique? Why do we need this? Well, the reason why we need this is we need to have some way inside of the service provider core to differentiate, or I should say at the provider edge, not the provider core. At the service provider edge, we need to be able to segment customer A traffic from customer B traffic. The way that we do that is, one, with the VRFs on the the PE router facing the customer. But once the routes from the customer have been received by the provider, we need to be able to take that information and do something with it. What ends up happening is when, say, R13 here takes a route and we advertise it to CSR1. CSR1 receives that in on the VRF enabled interface, and then what's going to happen is what would have already needed to be done, or what will need to be done in the future in order for this whole process to work, is a BGP peering needs to be set up between CSR6 and CSR1. Now this can be done in a full mesh style design. It can be done in a route reflector design. We'll be taking a look at both in upcoming videos. I'm going to first do the full mesh because it's going to be not too terribly difficult to do that, and then I'm going to migrate over to a route reflector design so you guys can see the differences. Now, in terms of how that comes into play, we need to understand why that's important. Well, the main reason why it's important is when I have a VPN-v4 or a VPN-v6 peering set up between CSR1 and CSR6 via BGP, this is going to allow the VPN-v4 process to allocate labels from the global label space that's available on all of the provider edge routers that are going to be allocated to customer learned routes that are learned in on the VRF enabled interfaces. So that means when when R13 here advertises a route to CSR1, let's say that R13 advertises loopback 0, whatever loopback 0 might be. That gets advertised to CSR1. Loopback 0's route is learned on CSR1. What's going to end up happening is CSR1 is going to allocate a label for that via the VPN-v4 process. The VPN-v4 process is going to go up to the global label space, grab a label value, or grab the next available label that's open, allocate it to this particular prefix, and then what's going to end up happening is through the peering, through this IBGP point-to-point connection, CSR1 is going to propagate that information across the wire to CSR6. CSR6 is then going to receive that and know what VPN label to allocate. So that leads us into our next case, where we're going to have actually a 2-label stack. The first label is going to be what they refer to as the top label. The second label is going to be the bottom label, also referred to as the VPN label. The top label is allocated via LDP, and it is used to get from the ingress PE router to the egress PE router. So let's assume that the flow is R13 to R15, so from the left over here across the wire to the right over here. Well, in that particular case, then CSR1 would use a label that was allocated to reach via CSR6 via the LDP process, and he would use whatever label was allocated. So he would look in his routing table, and see, do I have a route to CSR6's loopback? The answer to that question should be, yes, I do. So let me go ahead and forward the traffic via that label binding. Whatever that label binding is added, and then it's sent across the wire to CSR2, and then whatever the shortest path to CSR6 might be. CSR6 then receives that traffic, and then what's going to end up happening is it's going to look in its MPLS forwarding table and then know based off of the traffic that it needs to send traffic out to R15. Well, okay, how does it know that? Well, how it knows that is actually pretty unique. And to back the train up just a little bit, let's assume that XRV11 is the actual next hop in terms of reachability to CSR6. Traffic doesn't go through CSR5, it goes through XR11. What's going to end up happening is on XR11, the process known as the penultimate hop pop is going to take place. What does this mean? This means that CSR6 and XR11 are actually directly connected to each other through this physical connection, right? Well, what's going to happen is CSR6 is going to advertise what they call the implicit null value. The implicit null value goes, okay, I am directly connected to you, so therefore I want you to pop. It's called the penultimate hop pop process, I want you to remove the top label when you receive it. And what I want you to do by removing the top label, I want you to send to me the traffic from R13, but I want you to send it to me with only the VPN label in the label stack. So you're going to go from a 2 label stack down to a 1 label stack. When you do the 2 to 1 label stack migration, so you do the pop, you send the traffic from XR11 down to CSR6. By doing this, CSR6 receives the traffic with the VPN label. So when CSR6 looks at its MPLS forwarding table, let's say that CSR1 allocated label 21 for the route learned from R13. When label 21 is received inbound on CSR6, he is going to know that that is a customer route. So the outgoing interface is going to be this. It's also going to be related to a VRF, and it's going to know to send that traffic out the VRF to CSR or R15 in order for the Florida site to receive its traffic. That, in a nutshell, is basically how the MPLS process works. But you need to understand all these steps and how they come into play. Now, if you don't really understand this whole process and stuff like that, that's okay. I don't expect you to memorize it off the top of your head. That's why I'm going to go through a number of videos in order to walk you through the process. So let's actually talk about that. What is going to be the flow that we're going to go through in order to get all this stuff working? So let me go ahead and flip over to a text-based setup here so that you guys can see the actual flow that we're going to go through. So I'm going to actually pause the video. I'm going to make the modifications. They're going to be listed up over here, and we're going to go ahead and discuss that here in just a second. So I have listed above my head, right up here, what the flow is that we're going to be going through in order to set up the MPLS L3 VPN. Now I'm keeping this very straightforward, so even if you are studying for the new enterprise infrastructure CCIE, or you're going for the current routing and switching CCIE, or you're planning on covering MPLS in CCNP service provider, or CCNP route switch, or CCNP core, or enterprise core, whatever they're calling it now, I really don't care, right? Whatever you're using this training for, I really don't care. Hopefully it benefits you, and that's the whole purpose of the video is to do. So this is going to be the flow we're going to go through. We're going to start off with, we're going to do the IGP and LDP, then we're going to do VRFs, then we're going to do the IBGP VPN-v4 full mesh, then the IBGP VPN-v4 route reflector. We're going to do that on CSR4 and XRV10, so you can see how it's done on both. Then we're going to do our P2C routing, which will be the last step. We're going to do the BGP first, because that's going to be the most common design that you're likely going to ever see. And then we're going to do RIP P2C routing, ISIS P2C routing, OSPF P2C routing, EIGRP, and then static routing. Now, by the time we get done with all of this, we're going to have to go back and turn some features on and off as we're going along, because there will be some certain things like BGP has some capabilities like site of origin and having multiple right here we have this site AS10 over here is actually dual homed to the same provider. So we'll have to take that into consideration. There will be other things like OSPF and doing the sham links and doing site of origin for other routing protocols, so on and so forth. So we'll have to do some other capabilities. We will be doing some other capabilities like doing the route target import and export values and stuff like that. But those will be coming later on down the road. So this set of videos right here is what we're going to be going through initially in order to get the base functionality up and running. And then we'll go in there and we'll focus on some of the they're more obscure topics, which means they're not as commonly deployed, not as commonly seen, but we're definitely going to be covering them as we're going along, but they'll be coming out later on down the road. So that's what this entire setup is for. I want to bang these videos out, get them done, go through the detailed verification steps that we need to understand and go from there. If you are ready to go hang out with me and to go through this stuff, I am more than willing and happy to go through it myself, because in 2020, because now it is January 5th, 2020 at the date of this recording, right here, right now as I'm standing here talking to you in this recorded format, I want to go knock out my SPCCIE. So how am I going to go do that? I am committing to as much time as it takes in order to cover all the technologies and topics covered on the SP blueprint for Service Provider version 5. that's what I'm going to be doing. Plus some other technologies as I need to sprinkle them in there. Maybe I need to take a break from SP or whatever the case might be. I'm not trying to take a break right now, but I might need to be like, okay, I've been studying this for 3 months now. I need to like take a little bit of, take a week off, go focus on this, and then re-engage down the road. So, and so I want to take just a moment here and talk off topic just for a moment in terms of not being specific to what the topic of this video is, but more like some of my own personal motivation. How do I stay motivated in order to keep going and doing what I do? Well, there's actually a very simple answer to that. And I always feel, because of the fact that I've gotten to a certain point in my career, like I have a CCIE, but I don't feel like that's good enough, right? I'm always trying to do better than what I've already attained, and to me, that's what really makes a true engineer, is always trying to do better than what you've already achieved. Keep going, keep leveling up, keep doing your thing. Well, in order to do that, you need to put yourself into uncomfortable situations. So there are going to be some topics that I'm going to be covering here in the near future that I haven't really dealt with before. I want to dive into them. And one of the things that whenever I get like, am I actually doing the right stuff? And, is it worth it, this, that, or the other? Or I get some negative commentary on a YouTube video and stuff like that, which I leave the public comments open for a reason, because you know what? Everybody has the right to their own opinion. But one thing that I want to make very, very clear in this video, one, I never attack anybody in my videos. So I never want to go, I don't like being attacked personally. But if the comment is negatively geared, like if someone's attacking me or making fun of me in some way, I'm just going to delete it. There's no reason to, if you're watching this video at this point and you want to sit there and go blah, 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 Rob just doesn't ever know how to shut the hell up, I'm going to delete your comment, because that's just negativity I don't need in my life. I have enough baggage and enough other stuff to deal with that I don't need you ingesting your garbage into my life. As long as you understand where I'm coming from on that, we should be in good shape. A sidebar to that. One thing that really keeps me motivated, look up Jocko Willink, former Navy SEAL. He was a big dog in the Iraqi war. He went out and he's got a video. It's about 2 minutes long. It's called Go. Awesome video. You want motivation? I feel like I want to run through a brick wall after I get done listening to him talk. I will try my best to remember to link that video in the description of this video, and as many videos as I can think of in the future, because that's what keeps me motivated, is listening to guys like that I really haven't struggled in my life. And from what I can gather, Bud's training is like a kick in the balls. I've never personally had to go through that much trial and tribulation. Yes, earning a CCIE was difficult, but definitely nowhere near as difficult as trying to become a Navy SEAL. But with that being said, ladies and gentlemen, thank you for their continued support, and until next time, guys, take it easy.